There is no outside. That is the part the mind keeps rejecting, because every expansion you have ever seen has needed somewhere to go. Smoke expands into air. A balloon expands into a room. An explosion expands into the space around it. The universe does not do that. And if that sounds like an evasion, then the problem has already begun, because the question itself is carrying the wrong model of reality. I'm Christopher Vale, and you're watching Sleepy Explorer. Join me today as we take apart one of the most dangerous assumptions in cosmology. We are going to follow the evidence from the false image of a cosmic explosion to the geometry of expanding space, to the point where the word outside stops referring to anything at all. The question sounds innocent. If the universe is expanding, what is it expanding into? Almost everyone asks it sooner or later, usually after seeing galaxies scattered across a black background, drifting apart like sparks from a detonation. It feels like the obvious next move. That feeling is the trap. Your brain is not being foolish when it asks the question. It is doing exactly what it was built to do. It takes something abstract and forces it into a pattern that has worked on Earth for as long as human beings have been opening doors, filling cups, inflating lungs, watching clouds spread across the sky, and seeing fire push smoke into the air above it. Every expansion you know has an environment around it. A drop of ink expands into water. A storm expands across an atmosphere. A blast wave expands through air because the air was already there, waiting to be compressed and pushed aside. Expansion, in ordinary life, means something grows into a larger space. So when someone says the universe is expanding, the mind makes a silent move. It imagines the universe as an object. Then it places that object inside a larger emptiness. Then it watches the object swell. It makes sense. It is wrong. Modern cosmology does not answer the question by pointing to a larger void. It does something colder. It removes the void. It says the structure required by the question is not part of the model, not part of the evidence, and not part of the universe as we currently understand it. There is no container. There is no surrounding darkness with the universe sitting inside it. There is no wall, no outside surface, no border where space ends and some other medium begins. The question asks for a location that the physics does not supply. Wait. Think about that for a second. This is not a trick of language. It is not a clever way to avoid giving an answer. Physicists are not refusing the question because they want to sound superior. They refuse it because the question assumes the universe is one object inside another object, and the evidence does not show that kind of universe. The cruelty of the answer is that it does not feel like an answer. It feels like someone has taken the map out of your hands and told you the map was never describing the territory. You ask where the universe is expanding into, and cosmology replies that the word where has already failed. That failure begins with the most familiar image of all, the Big Bang. The name is a disaster. It sounds like an explosion, and once that picture enters the mind, it is almost impossible to remove. A hot point detonates. Matter flies outward. Darkness surrounds it. The universe grows like a fireball in an empty arena. That image has infected almost every diagram, documentary, graphic, and casual explanation ever made for the public. You see a glowing sphere expanding into blackness, and the blackness feels like the answer. There it is. That must be what the universe expands into. No. That blackness is smuggled in by the artist. It is not part of the event. It is the background needed to draw the picture on a screen. The actual physics does not require a stage behind the stage. The Big Bang did not happen at a point inside space. It did not erupt into a pre-existing room. It was not a blast throwing matter through an already available emptiness. It was a condition of space itself, a hot, dense state of the entire geometry. That phrase sounds less dramatic than explosion. It is also far more destructive to intuition. An explosion has a center. A bomb has a location. The fragments travel outward through surrounding space, and the space they move through existed before the detonation. The event occupies a region smaller than its environment. The Big Bang was not that kind of event. It was not matter moving through space. It was the early universe, meaning space itself, time itself, matter, radiation, and the rules for measuring distance, all in a radically different state from the one we live in now. No arena, no exterior, no outside air for the blast to push against. The ground is a lie, not the literal ground under your feet, but the mental ground you stand on when you imagine the cosmos. You assume there must be a larger place that holds everything. You assume that because every useful human experience has trained you to assume it. Boxes have outsides. Rooms have walls. Islands have coastlines. Bodies have skin. The universe does not owe your nervous system that structure. Cosmology became dangerous to common sense the moment it stopped treating space as a passive emptiness and started treating it as something with behavior. Space can curve. Space can stretch. Space can carry waves. Space can define distance in ways that change with time. That last point is the entry wound. When scientists say the universe is expanding, they are not mainly saying galaxies are flying through space like shrapnel. Nearby galaxies can move toward each other. Galaxies inside clusters can orbit, collide, and merge. The Milky Way and Andromeda are on a slow collision course right now. So the phrase galaxies are moving away is already too simple. On very large scales, what changes is the distance between galaxies, because the space between them is stretching. The ruler is changing. The metric, the rule that tells the universe what distance means, evolves with time. Two galaxies can remain nearly at rest in their own local patches while the amount of space between those patches increases. That sounds like a calculation error. It is not. Imagine two marks on a rubber sheet, not walking, not sliding, not accelerating across the surface. Pull the sheet, the marks separate. Nothing about the marks themselves needed to move through the sheet. The sheet changed. Now remove the sheet. That is the hard part. The rubber sheet analogy helps for 3 seconds and then betrays you. It gives you something to picture, but it also gives you a surrounding room, hands pulling from the outside, and a material surface embedded in a larger space. The universe is not a rubber sheet sitting inside a warehouse. The universe is not expanding into the thing that stretches it. The stretching is the behavior of the universe itself. This is why the original question is so hard to kill. Every analogy we use to explain expansion secretly rebuilds the mistake. Balloons sit in rooms. Sheets exist in space. Bread dough expands in an oven. Ink spreads through water. Every image gives the mind an outside again. Physics keeps taking it away. There is no place beyond the universe in the model, because the universe, in cosmology, means all of space, not merely the matter inside space. If you imagine flying to the edge, you have already imported an edge. If you imagine looking beyond the edge, you have already imported a beyond. If you imagine the universe as a sphere expanding into blackness, the blackness is not science. It is your visual cortex asking for a backdrop. The accounting is brutal. The Big Bang happened everywhere. Not everywhere in a poetic sense, Everywhere in the operational sense that every region of space we can observe was once part of that hot, dense, early state. The place where Earth is now was there. The place where the most distant galaxies are now was there. No one location was the launch site. Run the clock backward, and distances shrink. Galaxies do not all fly back to a single address in space. Instead, the scale of space contracts. Every pair of sufficiently distant points gets closer. The density rises everywhere. Keep rewinding, and the equations of general relativity eventually break down. They point toward infinite density, which is not proof that the universe was literally a point. It is a warning. The theory is being pushed past the range where it can safely speak. That warning matters because people often turn it into the wrong picture. They hear infinite density and imagine the entire universe crushed into a tiny ball. Then they imagine that ball exploding outward. The old mistake returns in cleaner clothes. The better picture is harsher. The early universe may have been infinite already. Not an infinite emptiness filled with a small fireball, but an infinite hot, dense universe, with internal distances far smaller than they are today. Infinite space can stretch and still remain infinite. That sounds impossible, only because the mind treats infinity like a very large object. It is not. Doubling an infinite line does not create an edge. Stretching an infinite geometry does not require a bigger geometry around it. Every internal distance can grow, and yet there is no final wall being pushed outward into a surrounding void. No edge appears, no outside appears, no container appears. The question keeps losing parts of itself. First, the center disappears, because every observer in the expanding universe can see distant galaxies receding. Then, the explosion disappears, because the Big Bang was not matter flying into pre-existing space. Then, the boundary disappears, because the universe may be infinite, or finite in a way that has no edge. Then, the outside disappears, because the geometry does not need to be embedded in anything else to be real. What remains is not satisfying. It is not a neat sentence you can carry away and use at a dinner table. It is a forced correction to the way the human mind handles space. The universe is not expanding into anything. It is expanding. Those two statements feel incomplete because language was built for objects inside environments. The universe is the environment, not the environment inside something else. The environment, full stop. At least as far as physics can currently measure and model. If you are not uncomfortable yet, you have not been paying attention, because this does more than answer one popular question. It exposes a deeper weakness in the way we picture reality. We keep trying to stand outside the universe in our imagination, as if we could look at it from a safe distance. But there is no observation deck outside the whole system. There is no external camera angle. Every measurement we have is made from inside the geometry we are trying to understand. That is the confinement. We do not look at the universe from beyond it. We look at the universe from one small region inside it, using light that has crossed expanding space, carrying information from a past that no longer exists in that form. Even our evidence arrives, stretched, delayed, and filtered by the geometry it is meant to reveal. So the first answer is not really an answer. It is a demolition. The universe is not a balloon. It is not a blast. It is not a sphere moving into darkness. It is not a room getting larger inside a larger room. It is a self-contained geometry whose internal distances change with time. And once that is on the table, the investigation becomes sharper and more dangerous. The question is no longer what lies outside the universe. The question is what kind of physical thing space must be if it can grow without going anywhere. The first evidence did not arrive as philosophy, it arrived as light. A century ago, astronomers were not trying to destroy the human picture of space. They were trying to measure faint smudges in the sky. That sounds harmless enough, almost routine, until you realize those smudges forced physics to abandon the idea of a static universe sitting still inside an eternal dark. At the center of that break was Edwin Hubble, working in 1929 at Mount Wilson Observatory in California. The telescope there was the most powerful of its time, and it gave Hubble access to objects that had been argued over for years. Some astronomers thought those dim patches were clouds inside the Milky Way. Others suspected something much worse for human importance. They were not clouds, they were galaxies. That fact alone was already an injury to scale. The Milky Way was not the whole universe. It was one galaxy among many, and those other systems were sitting at distances so large that ordinary distance language begins to sound fake. Millions of light years, then tens of millions, then more. But distance was only the first cut. When Hubble and others studied the light from these galaxies, they found that the light had been stretched. The pattern of colors in starlight carries physical evidence, because atoms absorb and emit light at specific wavelengths. Hydrogen leaves one kind of signature, calcium leaves another. Astronomers can read those signatures like a barcode burned into light. In distant galaxies, the barcode was shifted toward the red end of the spectrum. That shift matters because light behaves like a wave. Stretch the wavelength and the light becomes redder. Compress it and the light becomes bluer. So when galaxy light arrived, stretched, it carried a message. Something about the space between the source and the telescope had increased the wavelength during the journey. The first clue was simple. Most galaxies were redshifted. The second clue was worse. The farther away the galaxy was, the stronger the redshift tended to be. Distance and recession were connected. Not randomly, not vaguely, with enough regularity that a law could be written from it. The farther a galaxy was, the faster it appeared to be receding. That is the sentence that made the universe unstable. Imagine looking north and seeing galaxies moving away, then looking south and seeing the same thing. East, west, above, below, every deep enough direction repeats the pattern. The sky does not show a stream of galaxies moving one way. It shows recession all around us. The first instinct is obvious. We must be at the center. If everything is running away from us, then we must be standing at the point of origin. That is what an explosion would imply. Put yourself near the blast point, and fragments fly outward. Stand at the source, and everything recedes. It makes perfect intuitive sense. It is the wrong conclusion. The universe is not telling us that Earth occupies a special throne. It is telling us that expansion has a geometry almost no human intuition is prepared to handle. Any sufficiently distant observer sitting in any typical galaxy would see the same broad pattern. From their sky, distant galaxies would also recede. The farther away, the faster. Every observer gets to feel central. None of them are. That is the first clean break from the explosion picture. An explosion has one center. The Big Bang model, properly understood, does not put the center anywhere inside the universe. The pattern Hubble helped reveal is not matter spraying away from one privileged location. It is a change in separation that appears from every location at once. The center has been removed from the evidence. Now, hold that against the image in your head. A glowing point blows apart. Pieces fly into blackness. Somewhere, if you could trace the motion backward, there is a place where the blast began. That picture predicts a direction. It predicts a source. It predicts a region you could identify as the old center. Cosmology gives you none of that. No central scar, no original address, no outer ring of debris, no single direction in which the universe has been launched. The pattern is not outward from here, it is outward from everywhere, which is another way of saying the word outward has stopped behaving normally. This is where the facts become physically hostile to the imagination. We are used to motion being something objects do through space. A car moves along a road. A bullet crosses a room. A shock wave spreads through air. In every case, the object changes position inside a background that is already there. But the galaxies in the expanding universe are not mostly acting like bullets from a blast. On local scales, they have their own motions. Galaxies orbit within clusters. Some approach. Some collide. Andromeda is moving toward the Milky Way, not away from it. That should bother you. If expansion were just a simple explosion, nearby galaxies should mostly share the outward pattern, but gravity binds local systems strongly enough to resist the large-scale expansion. Galaxies inside groups and clusters can remain tied together while the larger universe stretches between those groups. So the expansion is not the same kind of motion as a thrown stone. It is not a local velocity through a local space. It is a large-scale change in the distance between systems that are not gravitationally bound to each other. The galaxies are markers in the pattern, not shrapnel proving a blast. They reveal that something about the structure separating them is changing. The universe is not fleeing from Earth. Earth is inside a geometry whose distances are growing. There is a useful way to picture the betrayal, but it has to be handled like evidence, not truth. Imagine a loaf of raisin bread rising in an oven. The raisins are galaxies. The dough is space. As the dough rises, every raisin sees the other raisins moving away. No raisin is the center of the expansion inside the dough. The analogy works just long enough to show the geometry. Then it becomes dangerous. The bread sits in an oven. The oven sits in a kitchen. The kitchen sits on Earth. Your brain immediately asks what the cosmic oven is. It wants a larger room again. It wants the outside that the analogy quietly supplied. Delete the oven. Delete the kitchen. Delete the room around the picture. What remains is not a loaf inside space. It is a system whose internal separations are changing. The analogy cannot carry you all the way, because every physical analogy lives inside the very kind of environment the universe does not require. The same failure haunts the balloon analogy. Dots on the surface move apart as the balloon inflates. No dot is central on the surface. That captures something real about how every observer can see the others receding. Then the mind notices the balloon has a center. And now the analogy has betrayed the case. The center of the balloon is not on the surface. The surface is the model. The interior of the balloon is not part of the two-dimensional universe being represented. But because you can see the balloon from outside, your brain smuggles in a higher space, a room, an external vantage point. That is exactly the forbidden move. Not forbidden because physicists dislike imagination. Forbidden because it adds structure not required by the measurements. The universe does not need to be seen from outside to have distances inside it. A geometry can be defined by relationships within itself. You do not need a larger arena to measure what happens between points in the geometry. This is not decorative math. It is the central issue. If every galaxy sees the same recession pattern, then the expansion cannot be treated as debris flying away from one place. If the Big Bang happened everywhere, then the early, hot, dense state cannot be treated as a small object sitting in a larger emptiness. If distant galaxies recede faster with distance, then the change must be tied to the scale of separation itself. The crime is not motion. The crime is distance. That is why Hubble's discovery still carries so much force. It did not just show that galaxies are far away. It showed that the farther we look, the more the light appears stretched by the history of the universe. The observation linked space, time, and distance into one expanding pattern. And it did something else. It made the static universe look unstable. Before this evidence settled in, even Einstein had tried to hold the universe still. His equations of general relativity allowed space-time to curve and evolve. But a changing universe was not the comfortable expectation. A static cosmos felt more natural, more permanent, more like a stage on which stars and galaxies could exist indefinitely. The data did not care. A universe filled with galaxies receding in a distance-linked pattern is not static. It has a history. It was different in the past. If you run the expansion backward, the distances between galaxies shrink. The universe becomes hotter, denser, more compressed in its internal scale. That does not mean all matter came from one point in an outside void. It means the observable universe was once in a hotter, denser state everywhere we can trace it. The evidence points backward to an early condition, not to an explosion site. The difference is not subtle. One is a location. The other is a state of the entire system. This is where the name Big Bang keeps damaging public understanding. It suggests noise, blast, center, violence, and space waiting outside the blast. The real model is more severe. Space itself changes. The universe cools as it expands. Light stretches as it crosses the growing geometry. Matter clumps under gravity, while the large-scale background keeps evolving. There was no fireball expanding into the dark. The dark came later. That statement is not poetry. In the earliest phases we can describe, the universe was hot and dense. It was not a glowing ball surrounded by night. Night requires empty space and time, and observers and stars separated by distances. The early universe was not a lamp inside darkness. It was the condition of everything. So the old mental picture dies twice. First, there was no outside darkness for the universe to expand into. Second, there was no empty cosmic stage before the universe appeared on it. The stage is part of the thing being explained. You can feel why the original question survives anyway. The language fights back. Expanding into is such a natural phrase that removing the into makes the sentence feel broken. The universe expands. The mind waits for the next word. Into what? Into where? Into which surrounding medium? Nothing. Not because there is a hidden nothingness outside it, not because there is an empty black reservoir beyond a wall, but because the model does not contain the relation the word into requires. Into belongs to objects inside environments. The universe, in the cosmological sense, is the environment. The evidence from redshift forced this correction. The galaxies were not telling us where the blast went. They were telling us that the scale of the universe is changing. They were not pointing back to a central crater. They were exposing a centerless pattern. And this centerless pattern has a terrifying consequence for the human need to stand somewhere solid. You cannot step outside the system to confirm it. You cannot look at the universe the way you look at a balloon. Every observation is internal. Every photon used as evidence has crossed the same expanding geometry under investigation. The witness is inside the crime scene. That makes cosmology unlike almost every ordinary act of measurement. If you measure a table, you stand outside the table. If you measure a storm, you can watch it from orbit. If you measure an explosion, you can map the debris field from the surrounding space. With the universe, there is no surrounding space from which to make the map. There is only the internal record, redshift, distance, the cosmic microwave background, the distribution of galaxies, the way light bends, stretches, and arrives late from regions whose current state we can never inspect directly. The universe gives evidence, but never an exterior view. That is why the Hubble pattern matters so deeply. It is not just a historical discovery. It is the first major clue that our normal categories are inadequate. Center, edge, blast, outside, container, background, each one begins to fail under pressure. The galaxies are not lying. Our picture is. By the time you accept that, the question has changed shape. The issue is no longer whether distant galaxies are receding. They are. The issue is no longer whether the Big Bang was a conventional explosion. It was not. The issue is no longer whether Earth sits at the center. It does not. The harder question is what kind of universe can make every observer appear central, while giving no observer a true center. That requires a deeper tool than analogy. Rubber sheets fail, balloons fail, bread fails. Every familiar image drags in an outside. The evidence demands something stricter. It demands a theory in which space is not a container, but a physical geometry with its own rules. It demands a way to describe distance not as a fixed background fact, but as something the universe itself can change. It demands that we stop asking where the galaxies are moving and start asking what has happened to the rule that tells them how far apart they are. The next wound is mathematical. The crime scene was the rule for distance itself. And a rule is harder to picture than a blast. A blast gives the mind debris, heat, pressure, direction. A rule gives it almost nothing to hold. But in the expanding universe, the rule is the evidence, not the matter, not the galaxies themselves. The rule that tells one galaxy how far it is from another. That rule has a name: the metric. In ordinary life, distance feels so obvious that it barely seems to need a rule at all. You place one object here, another object there, and you measure the gap. A ruler tells you the length. A map tells you the road. A radar pulse tells you how long light took to return. The universe is not ordinary life. A metric is the mathematical object that defines distance. It tells you how to convert coordinates, locations, and intervals into actual, measurable separation. In flat space, the metric behaves the way your school geometry trained you to expect. Move sideways, move forward, combine those changes, and the distance follows the familiar pattern. Simple, clean, deceptive. That simplicity is what physics had to lose. Before Albert Einstein, space was usually treated like a fixed stage. It was the silent arena where things happened. Planets moved through it, light crossed it, objects occupied positions inside it. Space itself did not really do anything. It just waited. Newton's universe had gravity, motion, mass, and force. But the background was rigid. The grid was already there. You could imagine it stretching forever, absolute and unmoved, while everything else played out on top of it. That picture feels natural because it is close to the way human beings experience rooms, roads, fields, and skies. Einstein broke the stage. By 1915, general relativity had replaced the old background with something far more dangerous. Space and time were not passive. They had geometry. They could bend around mass and energy. They could change the paths of light. They could dictate the motion of planets without using gravity as an invisible pull in the old sense. Gravity became geometry. That sentence is famous enough to sound harmless. It is not harmless. It means the Earth does not orbit the Sun because the Sun reaches across empty space with a hidden rope. The Earth follows the straightest possible path through a curved space-time shaped by the Sun's mass. The path looks curved to us because the geometry itself has been deformed. The floor moved. Not the floor under your feet, but the deeper floor of measurement. The thing you assumed was fixed turns out to have structure. Put enough mass and energy in the system, and the rule for distance and time changes around it. That is already unsettling. Expansion makes it worse. Curvature near a star or planet is local. You can picture it, badly, with the old rubber sheet. A heavy ball dents the sheet. Smaller balls roll around it. The picture is crude, but it at least points in the right direction for a moment. Cosmic expansion is not a dent. It is the large-scale metric changing with time. In the simplest cosmological models, the universe is described with a scale factor, a number that grows as the universe ages. The scale factor is not a speedometer for galaxies racing through space. It is part of the rule that converts cosmic coordinates into physical distance. When the scale factor grows, distances between widely separated, unbound regions grow with it. The ruler changes length. Wait, think about that for a second. If the ruler changes, then 2 points can become farther apart without either point locally moving away in the ordinary sense. A galaxy can remain nearly at rest with respect to its local space, while the measured distance to another faraway galaxy increases because the metric between them has evolved. That sounds like cheating. It is not. It is what happens when distance is not treated as an eternal background fact. In general relativity, the geometry is part of the physics. The metric responds to the contents of the universe, and the large-scale universe evolves. Expansion is not something added on top of space. It is a behavior of the geometry described by the metric. The galaxy did not run. The distance grew. This is the conceptual cut that people miss when they ask what the universe expands into. They are imagining a universe made of objects moving through a larger arena. General relativity replaces that with a universe where the arena itself has dynamics. The arena is not expanding into another arena. The arena is changing internally. The accounting is clean. If you choose 2 distant galaxies that are not gravitationally bound to each other, the space between them grows as the scale factor grows. Choose 2 others farther apart, and the same process creates a larger increase in separation, because there is more expanding space between them. That is why the farther galaxy appears to recede faster, not because it was launched harder, because there is more metric between here and there doing the stretching. This is also why Hubble's law has the form it does. Recession grows with distance because the expansion accumulates across distance. A galaxy twice as far away sits behind roughly twice as much expanding space, so its separation from us increases faster. The pattern is not random motion. It is geometry acting at scale. The universe does not need a center for that. Every observer can see the same law because the rule works everywhere. Each observer looks out across expanding distances. Each observer finds that, beyond local gravitational complications, more distant galaxies recede faster. The same metric evolution produces the same kind of sky from every typical vantage point. No throne. No privileged witness, just geometry. That word can make the whole thing sound abstract, as if it belongs on a chalkboard and nowhere else. But geometry is not harmless abstraction when it decides what light can reach you, what galaxies can remain visible, and whether a question has any physical meaning. Geometry is the machinery of access. The machinery permits something that looks impossible. Some distant galaxies recede from us faster than light. That sentence should stop you. Nothing with mass can move through local space faster than light. That is not a suggestion. It is one of the central constraints of relativity. Send a spacecraft, a particle, a message, any physical object through its nearby space, and it cannot cross that local light speed limit. Yet cosmology says galaxies can have recession rates beyond light speed. The contradiction is fake. The discomfort is real. Those galaxies are not blasting through their local space faster than light. They are not outrunning photons in their own neighborhood. The recession rate comes from the expansion of the space between us and them. It is a rate of increasing distance due to the changing metric, not a local velocity through space. Two categories, same units, different crimes. Relativity restricts local motion through space. It does not say the distance between two faraway regions, measured across an evolving universe, cannot increase faster than light. No signal is sent faster than light. No spacecraft breaks the local rule. No observer watches a galaxy physically streak past at superluminal speed in its own nearby space. The geometry simply carries the separation beyond that rate. It makes no sense. Then it does. Imagine ants walking on a stretching surface. An ant's walking speed across its local patch is limited. But if the surface between two ants stretches fast enough, the distance between them can increase faster than either ant could ever walk. The ants did not violate their walking limit. The surface changed beneath the bookkeeping. Now destroy the surface again. Because the universe is not a surface in a room. The analogy only points to the category difference. Local motion is one thing. Expansion of the metric is another. Once that difference is clear, the faster-than-light recession stops being a loophole and becomes a diagnosis. The universe is not merely populated by objects. It is governed by a changing geometry that decides how far apart those objects are. That is why asking what it expands into misses the actual mechanism. The word "into" suggests the boundary of an object moving through external space. The expansion has no need for that boundary. The scale factor changes internal distances. That is enough. No exterior has been introduced. No outside has entered the case. The deeper problem is that we still want to know what space is. The metric defines distance, but the thing whose distance is being defined does not feel like nothing. Space can curve. It can stretch. It can carry gravitational waves, ripples in geometry produced when massive objects accelerate violently. It can expand across cosmic time. Nothing should not behave this way. Empty space is not ordinary emptiness. It is not the absence of all structure. In modern physics, the vacuum can have properties. It can affect particles. It can participate in the expansion of the universe. It can be curved by mass and energy. It can determine the path of light. A dead void cannot do that. So the old language fails again. We say empty space because there may be no air, no dust, no star, no planet in a region. But that does not mean the region has no physical character. It has geometry. It has fields. It has rules. It has measurable behavior. Space is not stuff in the familiar sense. It is also not mere nothing. That middle category is where intuition goes to die. The question, what is the universe expanding into, assumes space is like air inside a balloon, or water around ink, or darkness around a fireball. But the evidence says the expansion is not the movement of material into a medium. It is the evolution of the metric that defines the distances inside the universe. So, the actual question becomes harsher. What is this metric describing? Is space a fundamental physical ingredient, something that exists at the base of reality? Is it a relational structure, nothing over and above the distances and causal links among events? Is it an emergent pattern, something that appears only when deeper physics is viewed at large scales? Those questions are not comfortable. They are not settled. They are the reason the original question is not merely naive, but strangely useful. It fails, and by failing, it exposes the next level of the problem. The universe is expanding as space, but space is not yet fully understood. The metric tells us how distances change. General relativity tells us how geometry responds to energy and mass. Observations tell us the large-scale universe has been stretching for billions of years. Redshift tells us light has been pulled longer by that stretching. Hubble's law tells us the stretching accumulates with distance. The mechanism is strong. The ontology is bleeding. That is the word for the deeper injury. Ontology means what kind of thing something is, and space resists the category. It behaves too much like something to be dismissed as nothing. It lacks too many ordinary features to be treated like a substance. It has no surface you can touch, no edge you can reach, no outside you can inspect. Still, it sets the distances. It bends the light. It expands. This is why the original question keeps returning in different disguises. Once you accept that the universe is not expanding into a void, you ask what space is made of. Once you accept that galaxies are not racing through a pre-existing arena, you ask what makes the arena evolve. Once you accept that the metric changes, you ask what fixes the rules of the metric in the first place. The investigation does not end. It drops. And the next drop is unavoidable. If space itself expands, and if the Big Bang was not a blast in space but an early state of space, then the beginning did not happen over there. It did not happen behind the galaxies. It did not happen at the center of some ancient explosion. It happened wherever space was, which means it happened here. Here, under your feet. Inside the volume that now contains your body, your room, your planet, your star, and every ordinary thing you have ever used to feel anchored. That is not metaphor. The region of space you occupy was once part of the hot, dense, early universe, not adjacent to it, not downstream from it, not thrown out of it like debris. It was it, because every region was it. This is where the mind tries to escape. It wants to locate the beginning somewhere else. It wants a birthplace. It wants a direction. It wants to say the Big Bang happened over there, and then the universe spread outward until, much later, one cooling fragment became our local region. That is the old explosion picture, hiding in cleaner language. Kill it again. The Big Bang was not a location in space. It was a state of space. The early universe was not a fireball inside a room. It was the entire room, except room is already too small a word, compressed into a hotter, denser, more extreme condition everywhere. Everywhere means exactly what it says. The space now occupied by the Milky Way was in that state. The space now occupied by Andromeda was in that state. The space now occupied by galaxies whose light has taken billions of years to reach us was also in that state. No one region was the central furnace. No one region got to be the origin. The origin was a time, not a place. That sentence breaks a lot of bad cosmology. It also breaks a lot of casual imagination. We are used to events having addresses. A lightning strike happens at a point on the ground. A volcano erupts from a mountain. A bomb detonates at a location. A child is born in a room, inside a building, inside a city. the beginning of the observable universe does not behave like that. Ask where the Big Bang happened, and the most precise answer is not far away. It is not at the edge of the visible cosmos. It is not behind the cosmic microwave background like some hidden launch site. It happened everywhere that later became the universe we can observe, including here. The evidence forces the statement, and the statement feels almost illegal. But it follows from the metric. Run the cosmic clock backward, and distances between unbound galaxies shrink. The scale factor decreases. Radiation becomes hotter. Matter becomes denser. The universe becomes less like the cold, diluted structure we inhabit and more like a single hot plasma with no transparent space between objects. But the shrinking happens throughout the geometry, not toward a center. This is the critical distinction. When you rewind an explosion, fragments converge on a point. When you rewind cosmic expansion, the scale of distances decreases everywhere. Any observer, anywhere, rewinding their local view, would find the universe becoming hotter and denser around them. They would not find themselves traveling toward your location. They would not find a central crater. Everywhere gets compressed. That is the forensic signature. If there had been a central explosion, the evidence would carry a directional memory. There would be a privileged region, a special place from which the pattern began. But the universe, on large scales, does not show that kind of scar. It shows a more uniform background, the remains of an early hot state coming from every direction in the sky. The past surrounds us, not because we are central, but because we are looking backward through time in every direction. Light from far away is old light. The farther we look, the earlier the universe we see. At the deepest limit available to ordinary light, we see the universe as it was when it first became transparent. It comes from all around us, because every direction leads into the past. This is another trap. A sphere appears around us, and the mind says center again. We seem to sit in the middle of a cosmic shell. The earliest light arrives from every direction, so surely we must be at the center of something. No, we are at the center of our view, not the center of the universe. Any observer, anywhere, would see themselves surrounded by their own sphere of ancient light. Observation creates the apparent center. Geometry does not grant one. The universe keeps refusing hierarchy. Now take the same logic and push it beyond what we can see. If the universe is infinite today, or at least much larger than the observable portion, then the early universe was not a tiny finite object that expanded into a larger emptiness. It was already an enormous, possibly infinite expanse in a hot, dense state. An infinite, hot, dense universe. The words do not feel like they belong together. Hot, dense usually implies compact. Infinite usually implies endless. The mind tries to choose one, but mathematics does not have to. Infinite space can have any scale factor. Infinite distances can all be smaller than they are now and still extend without edge. Stretch an infinite line, and it remains infinite. Shrink it, and it remains infinite. No boundary appears because infinity was never a wall waiting far away. It is a statement about there being no final end to the coordinate range, no last point where the geometry stops. The universe did not need to fit inside anything. There is no larger box required to hold an infinite early plasma. The box is the mistake. The plasma was not in space. Space, as far as the model goes, was in that state. The density and temperature belong to the whole geometry, not to an object placed inside a background. That is the move that must be held without flinching. The early universe was not small in the sense of being a little ball. It was small in the sense that distances between things were smaller. If space was infinite, it was still infinite. If space was finite but unbounded, it still had no edge. In either case, the image of a little object expanding into blackness is dead, and yet the diagrams keep resurrecting it. They almost have to. You cannot easily draw all of space changing scale without putting it on a page, and the page becomes an outside. You cannot show an expanding universe on a screen without a black background, and the background becomes a fake void. The visual explanation saves one part of the idea and poisons another. This is why the balloon survives. The surface of a balloon is genuinely useful. Put dots on it. Inflate it. The dots move apart. No dot is the center of the surface. Every dot sees the others receding. The surface expands in a way that mimics part of the cosmic pattern. Then your eye ruins it. You see the balloon from outside. You see the air around it. You see the center inside it. You see the rubber skin embedded in the three-dimensional room. And suddenly the analogy has reintroduced everything cosmology had removed. It gives the universe an outside again. But in the analogy, the two-dimensional creatures living on the balloon surface do not need the room to define their geometry. They can measure distances along the surface. They can discover curvature through triangles and circles. They can watch the distances between galaxies increase as the surface stretches. Their physics can be written entirely in terms of the surface itself. The outside is useful to us because we are visualizing it. It is not required for them. Now, raise the idea by one dimension and remove the visual crutch. Our space can have intrinsic geometry. It can be structured from within. Its distances, curvature, and evolution can be described without placing it inside some higher room that we get to inspect. The mathematics does not demand the cosmic equivalent of surrounding air. Your imagination does. That is the suspect. The human mind keeps adding and embedding space because every curved object in daily life is seen from outside. A ball curves in a room. A hill curves above a landscape. The Earth's surface curves through three-dimensional space, and we can launch satellites high enough to photograph the curve. So when we hear curved space, we imagine space bending inside a larger space. But intrinsic curvature does not need that. A geometry can contain all the information needed to define its own shape through the relationships between points inside it. You can tell whether a surface is curved by measuring triangles on the surface, not by leaving the surface. If the angles do not add the way flat geometry says they should, the inhabitants can detect curvature without ever accessing an outside. That matters because the universe may be like that in the strongest possible sense. Self-contained. Not isolated inside a void. Not sealed inside a higher dimensional tank. Self-contained in the way a complete geometry can be described by its internal relations. It does not need an exterior to exist, expand, or be measured. That statement feels too clean, almost evasive, until you see the alternative. If you demand an outside, you have to explain what that outside is. Does it have space? If it does, then the universe was not all of space. If it does not, then calling it outside is empty language. Does it have time? Does it contain distances? Can anything move there? Can it be observed? Can it affect the metric? Most versions of the outside collapse under questions they were never built to answer. They are not theories. They are drawings. That does not mean higher dimensions or broader structures are impossible in all speculative physics. Some models do consider larger frameworks. But those ideas are not required to answer the standard expansion question, and they do not rescue the simple picture of the universe growing into ordinary empty space. If a deeper structure exists, it would not be the intuitive room your brain first imagined. The obvious outside is dead either way. Now the edge must die too. People often picture an expanding universe as a frontier, moving outward. Somewhere, they imagine, there is a last galaxy, then a final layer of space, then a border, then whatever lies beyond. That image is emotionally satisfying because it lets the universe be enormous but still object-like, a thing with a skin. Cosmology gives no such skin. If the universe is infinite, there is no last galaxy by definition. Travel in any direction, and there is always more. Not necessarily more arranged exactly the same way forever, but no final boundary where space stops. There is no outermost shell being pushed into a void. If the universe is finite but unbounded, there is still no edge. You could travel far enough in one direction and, in some possible topologies, return to where you began without ever hitting a wall. The space would be finite in volume but have no boundary. The edge would not be hidden. It would not exist. This is not comforting. It means our two cleanest options both deny the thing the original question wants. Infinite space has no outside edge. Finite unbounded space has no outside edge. Neither one expands into a container. Both describe internal distances changing inside a geometry that does not present a border. The question is now running out of organs. No center, no explosion site, no edge, no surrounding room, no cosmic skin. What remains is a universe whose structure must be understood from within, by measurements made inside the same system, whose global shape may extend beyond anything we can ever observe. The evidence can tell us a great deal. It can tell us the universe expands. It can tell us the early universe was hot and dense. It can tell us space appears remarkably flat on large scales. But it may not tell us everything. That is the next pressure point. A finite observer inside a possibly infinite or topologically complicated universe cannot simply step back and inspect the whole object. We see only a region. A vast region, yes. A region containing an obscene number of galaxies, but still a region. A window is not a wall. This matters because many people mistake the observable universe for the whole universe. They hear a distance, imagine a boundary, and quietly reinstall the edge. But the boundary of what we can observe is not the boundary of what exists. It is only the boundary of what light has had time to deliver to us. The universe beyond that limit is not outside the universe. It is outside our view. That distinction will become critical, because once the false edge of the Big Bang is gone, and the false edge of expanding space is gone, the mind turns to the one edge that seems real. The edge of what we can see. It looks like a border. It is a fog. A fog can still carry evidence. That is the part that saves us from complete blindness. The boundary of what we can see is not a wall, but the light coming from that boundary has been damaged, stretched, cooled, and encoded by the entire history of expansion. If you know how to read it, the fog becomes a forensic record. The record is called the cosmic microwave background. It is not the edge of the universe. It is not the surface of a cosmic object. It is the oldest light we can directly observe, released when the early universe cooled enough for light to travel freely instead of being trapped in a hot plasma. Before that moment, the universe was opaque. After it, photons could move. Those photons are still arriving. They have been traveling for almost the entire age of the universe, while space itself stretched their wavelengths until the original radiation cooled into microwaves. They reach us from every direction, not because we are central, but because every direction looks backward into the same early phase of the universe. The fog has a texture. That texture is faint. The temperature differences in the cosmic microwave background are tiny, around 1 part in 100,000. To the eye, if the eye could see microwaves, the glow would look almost perfectly uniform. Almost. Almost is where the evidence lives. Those tiny variations are not random dirt on a signal. They are the fossil pattern of density fluctuations in the early universe, the slight unevenness that gravity later amplified into galaxies, clusters, filaments, and the vast structure we observe today. Without them, the universe would be almost featureless. With them, matter had places to fall. The crime scene left fingerprints. Spacecraft, such as the Planck Observatory, measured those fingerprints with extraordinary precision. It mapped the microwave sky, not to make a pretty picture, but to extract the geometry of the universe from the pattern of early light. The spacing, size, and strength of those temperature variations tell cosmologists how space behaves on the largest scales we can probe. This is where the question changes again. We cannot step outside the universe and look at its shape. We cannot photograph the whole system from beyond it. We cannot fly outside the geometry and inspect whether it is flat, curved, finite, or looped back on itself. So the universe has to be interrogated from inside. Light becomes the witness. The cosmic microwave background lets us ask whether the large-scale geometry is positively curved, negatively curved, or flat. Those words are easy to misunderstand. Flat does not mean thin. It does not mean the universe is a sheet. It means the rules of geometry at the largest observable scales behave like the ordinary geometry you learned before the universe began attacking ordinary intuition. Parallel lines stay parallel. Triangles add up the way you expect. Distances obey the familiar rules, at least across the region we can measure. Positive curvature is different. It is the three-dimensional version of what happens on the surface of a sphere, where straight paths can eventually converge, and triangles can have angles that add to more than 180 degrees. Negative curvature is the opposite kind of deformation, often compared to a saddle, where the geometry opens in another way. Those comparisons are crude. They are still useful. The measurement comes down to whether the microwave background's pattern appears larger or smaller than it should under different geometries. If space is curved, the path of ancient light is distorted in ways that change the apparent scale of the fluctuations. The sky becomes a geometry test, written in microwaves. The answer, as far as current observations show, is severe. The universe looks flat. Not roughly flat in a casual sense. Flat to within a very small margin, about 0.5% in the best combined measurements. Across the largest region we can observe, space behaves as though the curvature is extremely close to zero. That should disturb you more than it probably does. A universe can have many possible curvatures. It could have been visibly closed. It could have been visibly open. It could have curved strongly enough for the evidence to announce the global shape with no ambiguity. Instead, the measured curvature sits so close to flat that it becomes almost accusatory. The accounting is too clean. There is a reason this matters for the original question. If the universe is flat, then the two most serious possibilities are both hostile to an outside. The first is the simplest. Space may be infinite, not enormous in the way an ocean is enormous, with a far shore somewhere beyond sight. Infinite in the strict sense that there is no end in any direction. If that is true, then the universe never had a finite outer surface. It was not a small object that grew bigger. It was an infinite geometry whose scale changed. Distances between points grew, density fell, radiation cooled, structure formed, but no border was ever pushed outward. An infinite universe cannot expand into a room. The second possibility is stranger. The universe could be flat and finite, if its topology is unusual. Topology is the way space connects to itself. Geometry tells you about distances and angles. Topology tells you whether traveling far enough in one direction might eventually bring you back to where you started without ever turning around. Think of an old video game screen where a character exits on one side and reappears on the other. That is not a perfect model, but it points at the idea. A space can have no edge because opposite regions connect. In 3 dimensions, the universe could, in principle, have a wraparound structure so large that we have not detected it. No wall, no boundary, no outside, just connection. That is finite, but unbounded. Finite means the total volume could be limited. Unbounded means there is no edge where space stops. The traveler never finds a final surface. The traveler only keeps moving through space, perhaps eventually returning from a direction that makes no intuitive sense. This option also kills the original question. A wrapped universe is not a box inside a larger room. The wrapping is an internal property of the space itself. You do not need an exterior to define it. You need only the rule that says how one region connects to another. The topology does the work from within. So the 2 serious options both say the same thing to your instinct. No. If the universe is infinite, there is no outer surface expanding into anything. If it is finite but unbounded, there is still no outer surface expanding into anything. The answer does not depend on which option is true. The word into still has nowhere to attach. That is the brutal part. We do not currently know which option is true. The observable universe is vast, but it is not the whole. A finite observation cannot prove infinity. It can only fail to find curvature or repetition within the region available to us. If the universe loops back on itself at a scale far larger than what we can observe, the pattern would hide beyond our horizon. Not because it is protected by a wall, but because light from far enough away has not reached us and may never reach us. Cosmologists have searched for clues. If space wrapped around on a detectable scale, the cosmic microwave background might show repeated patterns, matching circles or mirrored structures in different directions of the sky. The universe might reveal that we are seeing the same region more than once, viewed along different paths. The evidence has not forced that conclusion. No conclusive wraparound has been found. No clear repeating signature has made the finite, unbounded case unavoidable. The simplest reading remains that the universe is flat and possibly infinite, or at least so large that our observable region cannot distinguish it from infinity. That is a deeply uncomfortable result. Not because it is vague, because it may be permanently vague. There may be facts about the universe that are true but inaccessible. The universe either has a finite global topology, or it does not. It either extends forever, or it does not. It either loops beyond our horizon, or it does not. Those are not merely emotional questions. They may correspond to the actual structure of reality. But from inside this system, with a finite speed of light, a finite age, and an accelerating expansion, some global facts may never reach evidence. The universe may know its own shape. We may not. That sentence sounds irrational, but it is just observational humility. A fact can exist outside the region that can ever influence us. A structure can be real beyond the range from which signals can arrive. There is no law saying the universe must make its global architecture available to one species around one star at one moment in cosmic time. Science does not promise access to everything. It promises discipline inside what can be accessed. And what can be accessed already tells us enough to kill the old picture. The measured universe is not curved in a way that reveals a small closed object. The observable region does not show an edge. The microwave background does not behave like light coming from a wall. The galaxies do not show expansion from a center. The metric expands internally. Still no outside. This is where the human mind starts bargaining. Maybe the outside is beyond the observable universe. Maybe if we could only see farther, past the microwave background, past the galaxies, past the fog, then we would finally reach the border. Maybe the outside is hidden by distance, not absent in principle. No, that move confuses two limits. The observable limit is a limit of information. An edge would be a limit of space. They are not the same. Failing to see beyond a distance does not mean reality ends there. It means light from beyond that distance has not had the right history to reach us. A blindfold is not a wall. The observable universe is centered on us because observation is centered on the observer. It is not centered on us because the universe cares where we are. Move the observer to another galaxy, and their visible region shifts. Their horizon encloses different galaxies. Their oldest light comes from a different spherical shell. Their cosmic window overlaps ours, but it is not identical to ours. There is no single privileged window. That fact will matter more. As the investigation continues, the universe has not only a visible limit from the past, it also has a causal limit in the future. There are regions we cannot see yet, regions we may someday see, and regions whose current light will never reach us because the expansion is accelerating. But before acceleration enters the case, the flatness result leaves us with a stark inventory. The universe has no center we can identify. The Big Bang has no launch site. The expansion has no surrounding medium. The observable boundary is not a wall. The measured curvature is extremely close to flat. The global shape may be infinite or finite in a way that gives us no edge to touch. The original question is not getting harder. It is getting less grammatical. What is the universe expanding into? Every word after expanding keeps trying to place the universe inside something larger, but the evidence keeps describing a self-contained geometry, measured from within, stretching according to its own metric, with no need for an exterior surface. This is not a failure of imagination. It is the punishment for using the wrong imagination. The more accurate picture is colder. You are not inside a bubble moving through darkness. You are inside a region of a self-contained geometry, looking outward through ancient light, measuring curvature from a microwave afterglow, trying to infer the whole from a window that may be a tiny fraction of the real system. And the window itself is often mistaken for the thing it reveals. That mistake is the next trap. Because the number sounds physical. About 46.5 billion light years in every direction. It sounds like a radius. It sounds like a size. It sounds like a boundary. It sounds, to the container-trained mind, like the wall we were denied. It is not the wall. It is only how far the fog lets us see. And the fog is personal. That is the first thing to understand. The observable universe is not a universal object with a fixed boundary that every observer shares. It is a sphere of access centered on whoever is doing the observing. From Earth, that sphere reaches about 46.5 billion light years in every direction. The number sounds impossible. The universe is about 13.8 billion years old, so the mind immediately objects. If light has had only 13.8 billion years to travel, how can we see something whose present-day distance is more than 3 times larger than that? The answer is the same culprit again. Expansion. A photon can spend 13 billion years traveling toward us, while the space between its source and us stretches during the journey. The light does not need to travel 46 billion light years in the old static sense. It leaves a galaxy when that galaxy is much closer. While it crosses the universe, the metric grows. By the time the photon arrives, the place that emitted it is far more distant than it was when the journey began. Two numbers are being confused. Light travel time tells you how long the photon has been moving. Present distance tells you where the source is now, after cosmic expansion has stretched the separation during that entire trip. Both numbers can be true. They are not measuring the same thing. This is where casual imagination breaks again. It wants distance to be one clean fact. A thing is either 13.8 billion light-years away or 46.5 billion light-years away. Pick one. The universe refuses. In an expanding geometry, distance has several meanings depending on what you are trying to measure. There is the time the light spent traveling. There is the distance to the source when the light was emitted. There is the distance to the source now, after billions of years of expansion. Treat those as one number, and the model begins to look contradictory. The contradiction is yours, not the universe's. The observable universe is the region from which light has had time to reach us since the universe became transparent. That last word matters. Transparent. Before the release of the cosmic microwave background, ordinary light could not travel freely across space because the universe was filled with a hot, dense plasma of charged particles. Photons kept colliding. They scattered again and again off free electrons. Light existed, but it could not carry a clean image over long distances. The early universe was not dark. It was opaque. A glowing fog everywhere, dense enough that light could not escape into a clear path. Then the temperature dropped. About 380,000 years after the beginning of the hot, dense phase, electrons and protons combined into neutral hydrogen atoms. Once those free electrons were removed from the plasma, photons could travel without constantly being knocked around. The universe became transparent. That moment did not happen at a wall. It happened everywhere. The photons released then are the cosmic microwave background. They come to us from every direction because every direction points into a different line of sight through the same early transparent surface. That surface is called the surface of last scattering, meaning the place, from our viewpoint, where those photons last bounced off matter before traveling freely. But place is dangerous here. The surface of last scattering is not a shell at the edge of reality. It is not a physical membrane wrapped around the universe. It is the limit of how far back ordinary light can show us. Look past that, and you are not looking beyond the universe. You are looking into an era when light could not carry the kind of information telescopes need. The fog becomes a time limit, not a spatial wall. That distinction is not optional. If you mistake the surface of last scattering for the edge of the universe, you rebuild the old container with a new paint job. You take a visibility limit and turn it into a boundary of existence. You confuse what can be seen with what is there. The universe beyond our observable region does not need to be different. The simplest expectation is that there is more universe beyond it. More space, more galaxies, more structure, more regions with their own local histories, all beyond the range from which light has had time to reach this planet. The edge is in the evidence, not in reality. That is why the phrase observable universe is so dangerous. It sounds like a technical name for the whole cosmos. It is not. It is the part of the universe available to our instruments from our location at our time. It is not the universe. It is our window. A window can have a frame. The world outside the frame does not end. Move the observer, and the window moves. Place an astronomer on a planet in a galaxy 10 billion light-years from here, and that observer has a different observable universe. Their sphere includes regions we cannot see. Our sphere includes regions they cannot see. The two spheres overlap, but neither one is the privileged whole. Every observer is trapped inside a private horizon of evidence. That should make you uneasy, because it means the universe each observer can study is not the same as the universe that exists. Observation is local. Reality may be global. The map we build is not the territory, and the boundary of the map is not the boundary of the territory. Now put numbers back into the fog. Inside our observable sphere, the number of galaxies is enormous. Estimates have changed as surveys improve, but the scale is brutal. Roughly trillions of galaxies may exist within the observable region, each containing millions, billions, or hundreds of billions of stars. The arithmetic stops being emotionally useful almost immediately. You can say the number. You cannot picture it. If you counted stars one at a time, second by second, the exercise would outlive you, your descendants, your civilization, and the stable lifetime of the world that produced you. And that is still only the visible part. It is the part the fog permits. It is not the full account. The observable universe is obscene in scale, and still may be a local sample. That is the humiliation. A region large enough to break every human measure may be a tiny fraction of the whole. If the universe is infinite, then the observable region is not almost everything. It is 0% in the limiting sense. Not small. Zero compared with infinity. If the universe is finite, but far larger than what we can observe, the humiliation remains. We may occupy one visible sphere in a structure whose full shape is beyond recovery. The cosmic microwave background gives us clues, but clues are not omniscience. The fog does not become the universe just because it is the deepest fog we can penetrate. And the fog changes with time. As the universe ages, light from some regions that was once beyond our horizon can enter it. In a universe without acceleration, the observable region could keep growing in a more straightforward way, gradually bringing more of the cosmos into view. But our universe does not expand in the simple way that expectation wants. The expansion is accelerating. That fact will become more destructive soon. For now, it is enough to notice that the observable boundary is not one boundary. Cosmology contains several horizons, and confusing them creates false answers. The particle horizon tells us how far light could have reached us since the early transparent universe. The event horizon asks a colder question. What light emitted now will ever reach us? Those are not the same question. The observable universe includes objects we see as they were long ago, even if their present-day versions are now far beyond our future contact. Their ancient light can arrive because it left when conditions allowed the journey, but light they emit today may never make it. The space between us and them may stretch too quickly for the signal to close the gap. This is where the fog starts to become a prison. Not because there is a wall around us, because expansion controls causal contact. A galaxy can remain real, full of stars, planets, chemistry, and local history, while becoming unreachable to us in every practical and physical sense. It has not fallen off an edge. It has crossed a limit in what can ever exchange information with us. That limit is not visible as a surface in space. It is written into the future of the metric. But before the event horizon takes over the case, the observable trap has to be killed completely. There is no such thing as the edge of the universe at 46.5 billion light years. There is only the edge of our past light cone, the boundary of information that could have reached Earth since the early universe became transparent. Past light cone. The phrase sounds technical, but the idea is direct. You do not see the universe as it is now at all distances. You see along paths light has taken to reach you. The farther away you look, the further back in time you look. Telescopes are not just distance machines. They are time machines with strict limitations. When you look at a nearby star, you see it slightly in the past. When you look at a distant galaxy, you see it as it was billions of years ago. When you look at the cosmic microwave background, you see the afterglow of an era before stars existed. You never see the whole universe now. There is no cosmic now available to observation across all of space. Relativity already makes simultaneity subtle, and cosmic expansion makes distance-dependent evidence unavoidable. What you call the universe in a telescope is a layered archive of different ages, stitched together by light travel time. The image is not a snapshot. It is a record of arrivals. This is why the observable universe can look like a sphere around us without making us central. The sphere is created by equal light travel limits in all directions, not by our being at the physical center of creation. Stand anywhere, wait long enough, and your own evidence forms around you the same way. The center belongs to the observer, not the cosmos. The mistake is old. Humans look outward and find themselves in the middle of what they can see. Then they confuse the middle of sight with the middle of existence. Cosmology has spent centuries punishing that confusion. Earth is not the center of the solar system. The sun is not the center of the galaxy. The Milky Way is not the center of the universe. And the observable universe is not the universe. The downgrade continues. There is another reason the fog matters. It protects the original question from a false rescue. Someone might say, fine, maybe there is no edge inside what we observe. But beyond the observable universe, surely that is where the outside begins. That sentence fails at the first step. Beyond the observable universe means beyond our current information limit. It does not mean beyond space. It means beyond what light has delivered. Beyond our horizon. The most conservative expectation is more of the same cosmic fabric, the same broad laws, the same kind of large-scale structure, at least until evidence says otherwise. The boundary is in our access, not in the universe's existence. So the old question loses another hiding place. It cannot hide in the Big Bang. It cannot hide in a center. It cannot hide in curvature. It cannot hide at the observable edge. Each time the mind finds a surface, the physics identifies it as something else. A coordinate artifact, a visual analogy, a limit of light, a limit of time, a limit of causality, not an outside. The fog is not the final answer. It is an autopsy report on our viewpoint. And it tells us something colder than the absence of an edge. It tells us we are late enough to see the ancient afterglow, but not powerful enough to see the whole. We live inside a temporary observational condition where the cosmic microwave background still reaches us, distant galaxies still carry evidence of expansion, and the large-scale structure still preserves traces of the early universe. This condition will not last forever. If the expansion were merely continuing, that would be strange enough. But the rate itself changed. The universe did not simply begin expanding and slow under gravity, as many expected. The evidence eventually showed the opposite. The expansion accelerated. The fog is being pulled away. And beyond the fog, something worse than invisibility begins. Not darkness. Disconnection. That is the worst thing. A galaxy can remain real and still become unreachable. Its stars can burn. Its planets can orbit. Chemistry can continue there for billions of years. But if the space between that galaxy and us stretches in the wrong way, no light it sends today will ever arrive here. That is not an edge. It is a verdict. For most of the 20th century, the reasonable expectation was that cosmic expansion should be slowing down. Gravity attracts. Matter pulls on matter. Galaxies, clusters, gas, dark matter. All of it should act like a brake on the expansion that began in the hot, dense, early universe. The universe might keep expanding forever, or it might eventually slow enough to recollapse. But the instinct was simple. Gravity should drag. Then the data refused. In 1998, two independent teams studying distant exploding stars found the wrong answer. One group was led by Saul Perlmutter. Another involved Adam Rice and Brian Schmidt. They were using a specific kind of stellar explosion called a Type 1, a supernova, a thermonuclear detonation that can act as a cosmic distance marker. These explosions are useful because their true brightness can be estimated with unusual reliability. If you know how bright something really is, and you measure how dim it looks from Earth, you can infer its distance. It is the same basic logic as judging how far away a streetlight is by how faint it appears. Except the streetlights are dying stars, scattered across billions of years of cosmic history. The job sounded straightforward. Measure the supernovae. Compare their distances and redshifts. Reconstruct how expansion changed over time. The expectation was deceleration. Distant supernovae should have fit a universe where gravity had been slowing the expansion. The teams measured them carefully, checked the brightness, checked the redshift, checked the assumptions, and found that the supernovae were too dim. Too dim means too far away. The galaxies hosting those explosions were farther than a slowing universe predicted. The expansion had not been losing speed in the way the standard expectation required. It had done something more disturbing. It had sped up. That is the line where modern cosmology changed shape. The expansion of the universe is not merely continuing, it is accelerating. The distance between unbound cosmic structures is growing faster with time, not slower. And the thing driving that acceleration is not ordinary matter. Matter pulls inward. Something else is winning. Cosmologists gave that something a name that is honest precisely because it explains almost nothing. Dark energy. It is dark because we do not understand its nature. It is energy because its effect enters the cosmic accounting as something that drives accelerated expansion. The name is not the answer. It is a label on the wound. Current estimates put dark energy at roughly 68% of the energy content of the universe. Most of the remaining share is dark matter, another unresolved problem, with ordinary atoms making up only a small fraction of the total. The things that make stars, planets, dust, oceans, bone, and blood are not the dominant contents of the cosmos. They are residue. If that does not feel like a demotion, the numbers have not landed yet. The acceleration does not mean the universe has found an outside and started pushing into it harder. That would be the old mistake with a new engine attached. Dark energy does not provide the missing external void. It does not supply cosmic air for the universe to displace. It does not create a surrounding chamber. The change is internal. The metric stretches at an increasing rate. The rule that converts separation into physical distance evolves so that widely separated regions pull away from causal contact more aggressively as time goes on. Space is not moving into something. Space is changing its own scale faster. That sentence sounds almost calm. Its consequence is not. If the simplest model is right, dark energy behaves like a cosmological constant. In that picture, empty space has a fixed energy density built into it. Every volume of vacuum contains the same tiny amount of this energy, and because the amount per volume does not dilute as the universe expands, more space means more total dark energy. More space, more vacuum energy, more acceleration. The loop is obscene. Ordinary matter thins out as space expands. Radiation thins out and redshifts away. But a cosmological constant does not fade with volume in the same way. It remains there, attached to the vacuum itself, and its gravitational effect in general relativity drives the expansion faster. Empty space is not empty enough. That is the simplest version. It fits a great deal of the evidence. It is mathematically clean. It is also physically humiliating, because we do not know why the value has the size it has. The measured dark energy density is tiny by everyday standards, but cosmologically decisive. It is small enough not to rip apart galaxies or solar systems, yet large enough to dominate the fate of the universe. Too weak locally, decisive globally. There are alternatives. Dark energy might not be a constant. It might be some evolving field, changing slowly over time. Some recent measurements from the Dark Energy Spectroscopic Instrument have raised the possibility that dark energy may not be perfectly constant, though the evidence is still debated and not settled. The current case is not closed. Good, because certainty here would be suspicious. If dark energy changes over time, the future of the universe changes with it. The acceleration could behave differently than expected. It could weaken, it could strengthen. It could lead to futures more complex than the clean cosmological constant picture. The data is still being pressed, cross-checked, and challenged. But none of these options restores an outside. That is the key. Whether dark energy is a constant or an evolving field, whether the acceleration is simple or more complex, the expansion is still not expansion into a larger room. The acceleration modifies the internal history of the metric. It changes how distances grow inside the universe. It does not introduce a border that moves outward into surrounding space. The old question gains no oxygen. Dark energy makes the universe stranger, not more intuitive. It says empty space may have a physical effect. It says the dominant component of the cosmos may be something we cannot isolate in a laboratory in the way we isolate ordinary matter. It says the fate of galaxies depends on a term in the equations whose origin remains unresolved. If you want a clean universe, you are in the wrong one. Now, follow the acceleration forward. In a decelerating universe, more and more light from distant regions might eventually reach us because time would keep adding to the range of what could be seen. The visible universe could grow in a way that feels at least somewhat generous. Wait long enough, and more of the cosmic record arrives. Acceleration changes the contract. As space stretches faster, distant regions can be carried away so quickly that light emitted from them now will never reach us. Not because the light stops, not because it violates its own speed. The photons still travel locally at light speed. They still move through their nearby space exactly as relativity allows. They simply lose the race against the expanding distance. That is the cosmological event horizon. It is not the edge of the universe. It is not the edge of the observable universe. It is not the surface of last scattering. It is a future limit. It marks the distance beyond which light emitted now can never arrive here, given the expansion history of the universe. A horizon is not always a wall. Sometimes it is a sentence about what can never be communicated. The event horizon sits much closer than the outer boundary of the observable universe. The observable universe reaches tens of billions of light years in present distance. The event horizon is around 16 to 17 billion light years away, depending on the model. That means there are objects we can still see from ancient light whose present-day versions are already beyond any future contact. They are visible ghosts. We see what they were. We cannot receive what they are sending now. That is a hard fact to absorb. A galaxy can appear in our telescopes because its old light left long ago when the geometry allowed the journey. But photons leaving that same galaxy today may never cross the expanding gap. Its past is in our archive. Its present is already unreachable. The universe has begun cutting the evidence away. This is not happening at one dramatic boundary you could fly to and touch. It is not a curtain moving across the sky. No alarm sounds when a galaxy crosses into permanent causal disconnection. The process is written into the expansion of space itself, silent and relentless, as the light paths that could once close the distance become paths that never do. The vanishing is causal, not visual, at least not yet. Far in the future, the visual consequence becomes absolute. Galaxies outside our gravitationally bound local group will drift beyond detectability. Their light will be stretched to longer and longer wavelengths. Their signals will fade, redden, and effectively disappear. The cosmic microwave background will cool and dilute until it becomes nearly impossible to detect. A future astronomer may look out and see a much emptier universe. Not because the universe became small, because the evidence left. That should make you stop. We live in an era where the universe still tells on itself. Distant galaxies remain visible. The cosmic microwave background still glows in the data. Large-scale structure still maps the history of expansion. The redshift pattern still reveals that space has changed with time. This evidence is temporary. Given enough time, a civilization in the far future, living inside a gravitationally bound island of galaxies, might infer a static local cosmos. The distant universe would have faded beyond reach. The afterglow of the early universe would be gone from practical detection. The expansion would have hidden its own case file. The crime scene cleans itself. That is the loneliest implication of accelerated expansion. It does not just move galaxies away. It removes their ability to participate in our causal future. It makes cosmology time-dependent in a brutal way. The truths available to one era may become inaccessible to another. The universe does not preserve evidence for our convenience. This returns us to the original question with a colder answer. What is the universe expanding into? Nothing. No container appears. But the expansion is not harmless. It creates horizons. It changes what can be seen. It decides which regions can ever exchange signals. It turns reality from our position into a shrinking causal archive, even while the total universe continues to exist beyond it. More universe, less excess. That is the paradox acceleration gives us. The universe grows in scale, but our meaningful connection to much of it contracts. The metric stretches, and the list of reachable places becomes shorter. Existence and contact separate. The galaxies beyond the event horizon are still there, if there remains any sensible global meaning to there in this context. Their stars are real. Their histories are real. Their local observers, if any exist, are not dissolved by our inability to see them. But from our causal future, they are gone. Still there. Gone forever. That is the kind of contradiction the human mind hates, because it exposes the difference between reality and access. We want existence to mean reachable, visible, confirmable. Cosmology says no. Something can exist and still be permanently outside every future measurement we can make. Not outside the universe. Outside us. The distinction is everything. And dark energy is the mechanism tightening it. Whatever it is, it has turned expansion from a historical fact into an active erasure of contact. It has made the universe not only centerless and edgeless, but increasingly unreachable across its own distances. The next question should be obvious. If space can expand, accelerate, create horizons, stretch light, erase evidence, and possibly carry the dominant energy of reality in its emptiness, then space is not the passive nothing we once imagined. Something is wrong under the floor. Under the floor of cosmology is the thing cosmology depends on and cannot fully explain. Space. Not stars, not galaxies, not dark matter, not even dark energy, though dark energy is the wound that makes the problem bleed in public. The deeper issue is that all of these phenomena happen inside a structure we still struggle to define without using the very structure we are trying to explain. We measure space with light moving through space. We describe space with equations written from inside space. We infer the history of space by watching the stretched remains of signals that crossed space while space itself was changing. That is not a clean laboratory setup. It is an investigation conducted from inside the evidence. Every telescope is internal. Every detector is internal. Every ruler, clock, atom, photon, and observer belongs to the same physical system whose origin and expansion are under examination. The witness never leaves the crime scene. This is why the old question fails so completely. What is the universe expanding into? It assumes space is already understood. It assumes space is the kind of thing that can sit inside more space. It assumes expansion means movement into a surrounding background. But the real problem is not the missing background. The real problem is space itself. General relativity tells us space-time has geometry. It can curve around mass and energy. It can expand on large scales. It can carry gravitational waves. It can generate horizons. It can decide which regions remain causally connected and which are removed from future contact. That is an extraordinary list of behaviors for something people casually call empty. Empty space is not empty in the way a clean box is empty. A clean box still has volume, geometry, fields, quantum fluctuations, and the possibility of measurement. It is empty of familiar objects, not empty of physical structure. The vacuum has properties, and those properties appear to matter at the largest scale we can observe. Dark energy made that impossible to ignore. If dark energy is a cosmological constant, then the vacuum itself carries an energy density that does not dilute as the universe expands. That one idea explains the acceleration well enough to sit at the center of the Standard Model. It also creates one of the worst mismatches in modern physics. The vacuum should not be this quiet. When physicists try to estimate vacuum energy using quantum field theory, the result can be catastrophically larger than the observed value. Depending on how the estimate is framed, the mismatch is often described as around 10 to the 120th, not 10 times too large, not a million, a 1 followed by 120 zeros. That is not a rounding error. That is the universe laughing at the ledger. The measured value of dark energy is tiny enough that galaxies, stars, planets, and atoms can exist. It is not zero. It is not huge. It sits in a narrow range that lets the universe form structure before acceleration dominates the future. If it were much larger, matter might have been pulled apart from the large-scale structure too early. Galaxies may never have assembled in the form needed for stars like the Sun and planets like Earth. The number looks almost selected. That is dangerous language, so handle it carefully. Selected does not mean designed. It does not mean chosen by an intelligence. It means the value has the appearance of being unusually compatible with structure, and physics does not yet have a satisfying explanation for why it takes that value. There are proposed answers. Some invoke deeper symmetry. Some invoke unknown fields. Some invoke a multiverse, where many regions or universes have different vacuum energies, and observers can arise only in the rare regions where the value allows galaxies. That move changes the room. It does not fully solve the floor. A multiverse, if real in some form, might explain why we observe a vacuum energy compatible with our existence. But it does not magically answer what space is, why the larger structure exists, what gives it laws, or why any of the underlying machinery should generate regions at all. It may move the question upward, not eliminate it. The outside returns wearing a better suit, and it still cannot be treated as ordinary empty space beyond a wall. This is the pattern again and again. Every time the mind wants a larger container, physics either refuses the container or turns it into another system that needs explaining. If our universe is one region in a larger framework, then that framework is not the simple black emptiness people imagine beyond an edge. It has rules, it has structure, it has some relation to time, causality, fields, or geometry. The question survives only by becoming harder. Then there is the Hubble tension. The expansion rate of the universe can be estimated in more than one way. One method looks at the early universe, especially the cosmic microwave background, and uses the standard model to infer the present expansion rate. Another method measures the late universe more directly, using distance ladders built from objects such as Cepheid variable stars and Type 1, a supernovae. They do not perfectly agree. The early universe estimate and the late universe estimate differ by enough that many cosmologists have taken the tension seriously. It may still be influenced by unrecognized systematic errors. Measurement in cosmology is brutal, and every rung of a distance ladder carries risk. But if the tension is real, then the standard model may be missing something. Wait, think about that for a second. We are not merely uncertain about what the universe expands into. We may not even have the expansion rate fully settled. The model that answers the popular question also contains pressure points inside its own machinery. It works astonishingly well across many observations, but it is not complete. The case is strong. The case is not closed. That is the correct discomfort. The standard model of cosmology gives a powerful account of the universe's large-scale history. It includes a hot, dense early state, expansion, structure formation, dark matter, dark energy, and the cosmic microwave background. It explains a great deal with a small set of parameters. But a good model is not the same as final reality. It is a weapon against confusion. It is not a license for arrogance. The future makes the humility sharper. We live at an unusual time, not because the universe cares about us, but because the evidence is still available. The cosmic microwave background is faint, but measurable. Distant galaxies remain visible. Their redshifts still trace expansion. Large-scale structure still preserves the imprint of early density variations. A future civilization may not have that luck. If accelerated expansion continues, distant galaxies outside the local gravitationally bound region will fade beyond detection. Their light will stretch until it becomes effectively unreachable. The cosmic microwave background will cool and weaken until it is buried beyond practical recovery. The evidence that revealed expansion may become inaccessible. The universe will not only hide regions, it will hide the fact that it hid them. A future astronomer, confined to a dark island of bound galaxies, might build a local astronomy and see no obvious sign of the wider expanding cosmos. The surrounding universe would still exist beyond causal reach, but the evidence would be gone. Their best available data might point them toward a much smaller and more static picture. They would be wrong. They might also be rational. That is the nightmare. Scientific truth depends on evidence, and evidence depends on cosmic timing. We happen to live in an era where the universe is still giving testimony. That testimony has an expiration date. The crime scene is being erased by the same expansion that created the case. And beneath all of it, space remains unresolved. In general relativity, space-time is smooth geometry. In quantum physics, the world is described through fields, particles, probabilities, and entanglement. These two frameworks are both successful, and they do not yet merge into a complete theory of quantum gravity. Something has to give. Black holes already tell us the tension is real. At their edges, gravity, quantum theory, information, and horizon physics collide. The early universe tells us the same thing from another direction. Run the equations backward far enough, and general relativity points toward a breakdown. It does not give us a final beginning. It gives us a warning that our theory has reached its limit. The map tears. Some modern ideas suggest space itself may not be fundamental. It may emerge from something deeper. One candidate is quantum entanglement, the strange linkage between parts of a quantum system that cannot be described as ordinary connection through space. In several lines of theoretical work, geometry appears to be related to patterns of entanglement. If that is even partly right, the consequences are savage. Space would not be the stage. Space would be the result. Distances, geometry, maybe even the smooth fabric described by general relativity could arise from deeper quantum relationships that do not begin as ordinary space at all. The thing you assumed everything happens inside may itself be produced by something more basic. That does not mean scientists have solved it. They have not. It does not mean we can confidently say space is made of entanglement in some simple way. Reality is not obligated to match the cleanest metaphor. But the direction of the question has changed. Not what is outside space. What gives rise to space? That is the real frontier. The old question imagines a universe expanding into a larger emptiness. The harder question asks why there is a measurable geometry capable of expansion in the first place. Why does the metric exist? Why does it evolve? Why does vacuum energy have the value it has? Why does the universe obey rules that make galaxies, observers, and questions possible? No cheap answer survives contact with those questions. You can say the universe expands into nothing, and that is the right answer to the old version. But it is not the full truth. The full truth is colder. The universe does not expand into a container because the container model is wrong. Expansion is the evolution of space itself. Space is a physical geometry with measurable behavior, and that geometry may not be the final layer of reality. The outside was never the missing piece. The missing piece may be beneath space. That is why the original question is useful, even though it fails. It fails in exactly the direction that exposes our assumptions. It shows that we imagine the cosmos as an object. It shows that we expect every object to have a surrounding space. It shows that our ordinary thinking cannot handle a self-contained geometry without smuggling in a viewpoint beyond it. There is no such viewpoint available to us. We are inside the expanding metric, inside the observable fog, inside the horizon structure, inside the age when evidence still arrives, inside a universe whose dominant energy is not understood, whose expansion rate may carry attention, whose vacuum energy mocks prediction, and whose space may be emergent rather than fundamental. That is the final inversion. The question began by asking where the universe is going. It ends by asking what space is. And the answer, for now, is brutally incomplete. Space is not a box. It is not air. It is not darkness around a blast. It is not a passive void that matter simply inhabits. It is geometry, measurement, causal structure, vacuum behavior, and possibly the large-scale expression of deeper quantum order. We know what it does better than we know what it is. That should be the sentence that remains. The universe is expanding, not into an outside, not through a pre-existing darkness, not from a center toward a frontier. Its internal distances are changing, its horizons are forming, its evidence is fading, and its deepest structure is still under investigation. If this leaves you unsettled, that is probably the correct response. A universe with no outside is not a comforting idea. It gives you no place to stand beyond the system, no final wall to point at, no external map to unfold. It forces you to accept that all our knowledge is built from within the thing we are trying to understand. If there is a final lesson here, it is not that the universe is too strange to question. It is that the first question was too small. What is it expanding into? Nothing. What is space? That is where the case remains open. And if that question stays with you after this, I'd be interested to hear where your mind goes first. Not because there is an easy answer waiting, but because this is the kind of problem that changes the shape of every answer we thought we already had.